Okay, let's start today's class. So if you watch the online video of the course, which is recorded here, you may notice that there's some technical issue in last lecture. So we were here for like an hour, 10 minutes, something like that, but the recording is only 28 minutes, so something is missing there. I'm going back a little bit, just quickly go through the stack example again in this class in order for everyone to learn that part. Okay, because that's sort of associated with the assignment, so I have to do this. Alright, so in the missing part of Monday's video, we basically went through an ADT, abstract data type, of a stack. Okay, so first what I did is I'm trying to emphasize why are we using this stack. I give several examples. Like here, we're trying to pair the parentheses, okay, the brackets. We're trying to see how can we solve the problem. Yeah, so we can solve the problem, yes, by writing some code, but it's going to be pretty complex process. You have to maintain some counters, and you need to detect if the counter reached negative, because sometimes you put the closing parentheses before the opening parentheses. That's not legal. Okay, a lot of things you need to consider. So sometimes we are solving the problem directly through some algorithm. Another way is we define some data structure to solve a problem. Here is a stack. Stack is a pretty good example, a pretty good data structure to solve this sort of problem, pairing the parentheses. Okay, like when you have a open parenthesis, you have to close it somewhere, and the opening, the number of open and the number of close should be the same. Okay, so that we are defining a stack in a manner of ADT. So what is the ADT? ADT is abstracted data type. So we are just talking about what's the data there, what's the operation of the data. But we also talk about the relations. Yeah, the three elements. First is we talk about the elements, individual elements in there. Then we talk about the relations among these elements. Then we talk about the operations on this element. Okay, so that's the ADT. But stack ADT, what we do is first we define it. We need to say this. We need to specify those three elements, important elements. First is the elements in the ADT. So in the stack, it's a collection of identically typed elements, one on top of another. Okay, and then we specify the relations between the elements. So they are one on top of another, and we place a new item on top of the stack. And when we remove the item, we take it off the top of the stack. So that's basically we're specifying the relations. Okay, then we specify the operations to these elements inside this ADT, which is the operations. Here we have push, pop, and peek. Okay, so why do we come with these three operations? That's because this stack, we are actually trying to simulate the real world stack, like a stack of book. What you do to that stack is first you push, like we put a book on the top, which is a push, and then we pop, like we took a book away from this, we pick the top book, we take it away from the stack. That's pop, okay? And then pick means, think about the real world stack. It's like the top book is always available there. We can see what is it without taking it away. All right. So that's the difference between pop and pick. Pop is we take it away, put it somewhere, and pick is we just look at it. What is it? But we do not take it away. Okay. Then when we define these operations, usually we define it with some ways, several ways. First is we just describe it, like here, push, insert object X at the top of the stack. Yeah. Or we can do pre and post conditions, like such as what we did in this document. So in this week 2, we have this abstract data type definition. Okay, so this actually defines the array, and it's defined with precondition and post conditions. Preconditions means the conditions that has to be met before you're doing this operation. Post conditions means the conditions that has to be met after you execute this operation. Okay. For example, here the operation for the retrieve operation of an array. Precondition is an array object that has been previously created. There is an array there. And we need an I, which is the index. That's another condition. Post condition means the value associated with index I in the array object is returned. Okay, so that's an example of a retrieve operation of an array. Let's go back to this stack. So for the push operation, did I specify that? No. Okay, we can talk about it. Okay, for the pre and post condition of push, can somebody tell me what is precondition of push?
There has to be a stack.
Yeah, there should be a stack there, created stack there. Yeah. Well, it can be empty because you're putting something there, right? Yeah. So you're putting something there. It can be empty. So I think that's first is there should be a stack created. Okay. Second is we have an object X to be pushed. Right? That's the second precondition. You cannot just call push without anything. Push the air. Nothing happen. And post condition. Yeah, object exists in the stack. Yeah, it has to be on top of the stack. Yeah, that's post condition. So X is on top of the stack. That's the post condition of push. Also, the third way we specify this operation is we're using this figure like this. Here we have before and after. So before we have stack of like 37, 20, 25, and then we push an X there. And after this push X operation, we have this stack on the right side with X on top. Okay, so 3 ways to specify. First describe, then pre-post condition, then this figure. Okay, so in the assignment, I want you to do all 3 of them. at least first two of them, the precondition, postcondition, and description. And if you think you can put a figure there and put the figure there, but if you think it may be hard to use the figure to describe some data structure, then you just ignore it. Okay.
I know this picture is for illustration purposes. Do we have to know the size of the stack before we?
Size.
Yeah. Do we need to define the size of the stack?
Well, here in ADT, you do not need to define the size, right? No. Okay, for this figure, it's only an example.
I understand.
Yes, example.
Generally speaking, when we are implementing the stack, don't we use maybe an array to implement it, or?
No, we're not done to the implementation.
Okay.
ADT is nothing about implementation. It's about the idea. Pop. So same thing. We remove and return the object at top of the stack, right? Pop. Also, peek is we return the object at top of the stack. Okay. So we're we can also use preconditions, postconditions, figures to illustrate this process or this process. Didn't I do that in the last class? Okay, it's fine. That's just a straightforward thing. Pop, you know what is pop. You can draw a picture of pop. You can draw a picture of peak, right? It's not hard. Okay, let's quickly finish with stack, which is I repeat it a little bit for the student who wants to watch the lecture video. Okay, now let's talk about something more about this ADT. Can somebody go to YouTube, search for my name and live, see if everything is on live?
Yeah,
it's working? Cool. Yeah, I don't know, somehow in the last class it stopped after half an hour. Okay. Now let's have a more complex ADT. Okay. Last time we modeled a stack. Okay, now if we want an ADT that model the dictionary, or you can say it's a map. I know what is dictionary, right? You check the meaning of some word. Okay, so it's a map between the word to its definition or its description. Definition, description, and examples. Okay, so that is something called a map, and then a dictionary or map. It's fine. So now we're going to trying to modeling this map dictionary. Think about it. Okay, what is the in the real world life? If we want to find the ADT of the dictionary, what could be the data there? Think about three elements, okay? As three aspects of an ADT. First is elements, the relations, the operations. Okay, think about three things. First, elements. What are the elements of a dictionary? String? Yeah, that's string. That's pretty down to the implementation level already. So we're not going there. And it could be a dictionary, yeah. It could let's think about dictionary. That's string is a dictionary, text dictionary. Let's think about a dictionary maybe in general, like yeah, like a key value pair. Okay, key value pair. Seems like something like that. Let's give a definition. So first is elements, right? The real world dictionary. We have this. The string you mentioned. What are those? Those are words, right? Those are words. We have the words. We have the description of the words, of those words. Okay. So we have two different things: words and the meaning. Right? So two sets. One is the word set, one is description set, one is the key, one is the value. Okay, so we give a definition that it's a dictionary. Dictionary is a dictionary that stores collection, right? Because we have a collection, a whole set of value, a key and a whole set of values, right? So it stores a collection of keys and their associated values. Does this describe the element? Yes. Yeah. So this sentence actually describes what are there. Yeah, elements. But we forget something about the elements. Huh?
Should be sorted.
Sorted. It could be sorted or not. In the dictionary, it's sorted. Yes. But we can do it not sorted. So the keys. They should be unique, right? The keys should be unique. You can just have only one.
But in an actual dictionary, it need not be there.
Yeah, but yeah, there's something like that. The word like repeated word, right? But the intention is like that's in a real word dictionary, okay? But at least you should have in a computer. You should have a like if you have two similar keys, it should be like key one, like word one or word two. You have to have a way to separate them. So important thing is if you want to check that key, check the value of that key. First, the key has to be unique, right? So that in that case, you want to check somewhere you have two different meanings, right? Let's assume here we have a dictionary that 1-to-1 pair, okay? So the keys needs to be unique. Unique keys and the associated values. Okay. Yeah, that sounds like the elements and their association, right? Let's think still we may have something missing. Like the association. We need to describe more about association. Is it one-to-one mapping or one-to-many mapping? Yeah, it's one-to-one, right? So we need to say it. We can say each key is associated with a single value. Or you can say it's a one-to-one mapping. Alright. So that basically specifies what's in there and their relations. Anything missing? think that's good. Yeah, it's a general dictionary. Looks like this. All right. Okay, and then let's think about the operations. The operation. Okay. Can somebody tell me any operations?
Be able to return a value for input
Yes,
key.
at least for a dictionary, we need to check some value for the associated key, right? So let's do the operations. Operations, okay. First is, we can say it's check or get. Usually we use get, if you're familiar with Java, those things. But it's basically it's check. When we check the dictionary, it's get. It's get. Okay, so we gave an object. We use what to get the value?
We use the key.
Yes, so the object key. Yeah, we use a key to get the value, okay. So basically what the get means, it just return, right, return the value. Why it's going there? Return the value currently associated with the key k. K is the object. We use that object as the key. Okay. Yeah. And when we are trying to retrieve the value, what is sort of like the exceptions there? Like when you check the dictionary, check, okay, this English dictionary.
Not found.
May not find.
Yeah, not find. You may not find the word you want to check. Maybe the word doesn't exist. You made it up, or your dictionary is not powerful enough. Okay. So, if we give a key that doesn't exist, we get nothing. It's not in the map. Now, yeah, we should return now. Okay. Yeah. So we can see a whole set of preconditions, post conditions. Let's see what is a pre and post for this one. Get object key. First, we should have a dictionary. Exists, right? Key of the type object. Key should be the object. You cannot just give something else, right? It's not the, this we say obj here. We can say maybe we use a string as a key. String is an object, right? We can use a string as a key. We can use integer as a key. If you use integer as a key, you cannot just give a string to say we want to retrieve something. If you're using string as a key, You cannot just say I want to retrieve something, check something with an integer. Okay, so key should be of the type of what we defined for the key.
Key should be of the type key, right?
K should be the type of key, yes, but here we want it to be general, so we just define an obj object. Yes. There's not a whole lot of post condition things. Just the value return. Yeah. Or no. Okay. Return no or the value associated value. Yes. Oh yeah, that's the most essential operation of dictionary. Okay. Then we what else can we do to the dictionary?
Loading the dictionary, does it come in this?
Loading.
Creating the dictionary, do we have to?
Yeah, that's construction method. Yeah.
We have to declare those also.
Well, I don't require that because everything you have a construction there, so just don't bother to specify it here. It's okay. It's okay. Just specify the essential part of it. And to me, the construction is more implementation level. Yeah. Okay, so get. We should get something, but before we get, we need to maybe put something in there, right? So the dictionary, you didn't put it, yes, but somebody else, they put all those associations, right? So put, okay. Do we have any parameters for put?
Object key and the value.
Yes, the object key and object value. Yes. So I just what you do is it's just place the pair. Place a V in the map with a key K. Yes. Anything else we need to mention in the put?
Key should not be already found, right?
Yeah. Right. That's one of the assumptions. Yeah. If we put something, it should not be there. But also we can modify something, right? If it's already there, we can modify it. So we can allow it's there. We can allow the existence there. We just need to specify if it's already there, we override it. Yeah, right? Because making a dictionary is not like when you first put something in there, it's done. You can modify, right? So if K if there's already a K, if K is already exists, okay, if K exists, K exists, nah. If K has a value already, if K has a value already, it is replaced by value. Okay. So it's gonna be something like this, and we can do some preconditions and post conditions in order to describe it in more detail, right? And we can draw. So I won't specify it here. You can finish it if you want. And another thing is that figure, right? If we want to trying to have a figure of this put, it's gonna be something like we have a pair, and then we put another pair there. Still before and after, right? Something like that. Just pretty abstract. Okay, one pair. Hey. Okay. Okay, it's something like before. Come on, it's a huge before. After, right? Before and after. Okay, but inside each of them it should be pair, key value pair, instead of a single value. So probably it looks like this. So assume it's a one-to-one pair. Okay. Alright, let's have some key. Okay, Joe. Okay, James. Blah 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 blah. Jane. So or starts with J. Okay. It could be its okay, phone number, right? 770 123 blah blah blah. Here it's the same for blah 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 770 blah blah blah. Okay, that's before. And we have a cell. We have another cell. We have another pair. Bob. 210 blah blah blah. Yeah. Okay. And then right. Okay, we also need to specify this is the key, this is the value. I just like something like this. I put it here. Yeah. Okay, so I'm doing this. It's not like you have to do it exactly the same way as I did. Just try your best to use a figure to illustrate something. There's no formal way to do this. Just this whole idea why we're using ADT is first understand, use it to model, and just abstractly describe something. Okay. So here, yeah, just put it here. All right.
Question. I don't know whether it's supposed to come in here. Aren't the keys or the values supposed to be sorted? So how do we it's
Okay. Well, since here I'm not actually defining any sorted dictionary, I'm just defining a dictionary, so you don't have to say it's sorted. Okay, but if you want to define a sorted dictionary, here you have to have more strict definition, right? You have to specify key is sorted, it's unique and sorted.
I was thinking we are modeling a real life
Dictionary, yeah, that's like you're modeling English dictionary, something like that. So we're modeling a dictionary. We're trying to generalize those dictionaries, English dictionary, other dictionary, name directory. We put it like a dictionary here. Okay, put get. What else? Is that all? What we do to the dictionary? We put something, then we can check. Is it?
Can we delete it?
Yes. Well, we have put, right? Then we should have something reverse that. Because then we can modify that. We can remove this whole bunch of things. Remove. Okay, and we remove what is a parameter. What is a parameter?
You have the key to remove the value.
Just a key?
Key and the value.
No.
Do you need a key or key and value?
Just the key. The key is
Yes. Key is unique. Key is associated with value. So we don't need the value. Sometimes maybe the value is huge and you don't even know what the value is. You just want to remove that key. Okay, I just want to remove this student from this class. I don't care what's the age of him or her, what's the, something like that, right? Okay, so key. Okay, and then you can do a whole bunch of similar things. Define, blah blah blah. Maybe I just put a definition here. So it's remove a pair, a key value pair. Key value pair. Associated with the key K. Yeah. Yeah, I think so. That's what we did. And sometimes it depends on what you need. Sometimes some implementation of it, it's actually when you remove it returns the value. But I think most of the time we do not return the value when we remove. We just remove, right? Sometimes it returns like true or false. Like if we find it and we remove it successfully, we return true. Otherwise, we return some false, something like that. You can define that to that detail here. It's okay. But here I'm not doing this. Actually, some other general operations of dictionary. Yeah, this three definitely should be here: get, put, remove. And also sometime we want to just destroy it, clear, right? You don't have to give any parameter, you just need to clear it. Most of the time we're not using that. And we check if it contains a key. Right, we can check that. Even we can check if it contains some value. Yeah, I believe most of the dictionary you can just grab that collection of key or grab that collection of value. Value, I'm not sure, but key, yeah. You can just get the key set. It will return a set of the key. Okay. Or value set. Let's assume we have that. Yeah, it returns a set of this value. Okay. That's typically a dictionary. But the most important thing, those three things there. And like the array, you can check the size. Of course, you can check the size of the key dictionary, or you can check if that's empty or not. As most of the time we do that. Yeah, it depends on what level do you want to specify this ADT, and for what purpose are you designing this data type? Okay, maybe for some data type, okay, for dictionary, because there are a lot of dictionary already there, we know contains key set, value set, is empty, size is there. But if you define your own, if you're defining your own ADT, probably you just have some essential operations there, and you ignore some other general, like size, those things. But if you want them to be there, you need to specify them here. Okay. All right, that's the ADT of a dictionary. Yes. Good. Remove. Yes. All right, that's about the dictionary. Let's save. Okay, next let's talk about, let's try to not talk about this dictionary, this queue, these things which already exist. Okay, now let's define something. Maybe you see that a lot in the real world, in your life, but you never consider that to model it as ADT. Okay, let's try that. So what we want to do is a little bit more exercises. Wait. Teaching. Stack. What's that? The dictionary. Yeah. Dictionary. Let me put it here in case I forgot. move. Okay, dictionary example is here. No, this one. So here in this abstract data type homework, I'm asking you to model a refrigerator. Okay. Now let's talk about it a little bit. Refrigerator. Okay, so consider this refrigerator's ice dispenser. It has this, ice dispenser. You all know what that is, right? Yeah. So it has water coming in, and then it starts create some ice cube, right? It has it can create ice cube or crushed ice or just some cold water, ice water, chilled water. Also, it also has maybe an out of ice indicator to tell you if the ice is there, or maybe some other sensor tell you something else. But let's make it simple. Let's just say we have one is out of ice indicator. Okay. Yes. Yeah, you can push all these buttons, right? All those buttons. So water come in, you press this water, and you've got this ice water. You press crushed ice, it has crushed ice. Okay. All right. So this is like a figure of that. Yeah, and also this ice dispenser, it has all those steel walls there, right? Yeah. So that the water won't leak, right? Something like that. All right. So let's look at this picture. So that's the ice dispenser. Let's consider this as an ADT, abstract data type. Okay, abstract data type, which means we're not implement that. We're not saying like how do we create chilled water? How can we crash the ice? What kind of like crash machine we machine, how the machine work? That's the implementation. Okay, maybe the machine use gas, electrical machine. Okay, anyway, but now let's see it as this ADT, abstract data type. Okay, so what are the operations?
Dispense, one of those options there, dispense chilled water or dispense crushed ice.
Yes. And ice cubes. Yeah, so those are the functions of a dispenser. So if we think this ice dispenser as an ADT, those functions are the operations, right? So we're doing the operations. Yeah, we're doing the operations. Okay. And then what is the data?
You want chilled water or crushed ice or ice cube?
You want the input data
Talk about the input or
or the output data?
Yeah, think about the ADT. When you're talking about input data and output data, that's the input and output of an operation, right? But if we think about ADT, abstract data type, what is the data of the array? That is all those data of the elements, that's data, right? What are the data of a dictionary? Keys and values. Keys and values. Yes. Yes. And different so yeah, different value of the data will create different status of that ADT. I mentioned that, I think, last time. So here, let's think about what is the data.
Maybe you could have like chilled water, ice, and crushed ice, and it has some values based on how much quantity it contains.
Yeah, chilled water, crushed ice, ice cubes. Yeah, those are, if you think about operation, those are data that output it.
No,
Yes.
but based on the values, if it is there, it can output it. If it is 0, it cannot output it. So it stores the quantity.
If it's 0,
Seems like the
Like
element in an array.
yeah.
So here, the elements are not of the same type. You know, like there are different types now. The fact that we have chilled water, and we have crushed ice, and we have ice cubes. So if we look at those as the elements in the,
Oh, yeah, I know what you mean.
so we have 3 different types of elements.
Okay, so let's see. Let's go back to operation. What is operation? What are operations? When we define operations in ADT, operations are the operations that does something to the data. Okay, does the crushed ice doing something to the ice cube? Does the crushed ice doing something to the ice, to the crushed ice? No, it just outputted. No, then nothing happened to the crushed ice, right? You get the crushed ice.
I mean,
But
if
when-
I would not implement, but if I would define it, it would be something like when we do get crushed ice, it would reduce the amount of crushed ice in the ADT and then give the output.
I didn't get it. Sorry.
So, like
Explain
what you
more.
said, those would be variables, the chilled water
Okay.
and ice cubes and everything, and the operation would be like get crushed ice. So it would
Okay.
reduce the quantity and return the crushed ice.
Okay.
If it
Okay, yeah.
has.
Yeah. That if you want to model crushed ice module, maybe that's something you want to do. Like you have crushed ice, you have an operation that is a get crushed ice or something like that. But let's go to this level, a higher level. Okay, here, just here. We say that operations does something to the data. So what is the data here? Water. Yeah, because all of the operations, they're doing something to the water. They're doing to different level, right? Just different level. So, but they are same, doing something to the water.
So this one, when they ask for this definition, it would be based on the understanding of the person, right?
Yes, there's no unique answer, but there is some way that like an answer maybe that's accepted by most people, I guess. Yeah. So we have to keep this in this level. So yeah, I understand that you say that we get chilled water. Yeah, but that might be more appropriate to specify that in the lower level. Yeah, maybe you want define the crushed ice module, that thing as an ADT. Then that probably should be there.
So what are we doing to the water right now? At this level, what are we doing to the water? What operation are we doing to the water?
What operations, like make it cold, like chilled water here. Okay, water is coming here and it does something to the water, right? It does. Otherwise, it cannot output something other than the original water. Okay, so all of 3 methods, they are doing something to water. Water is the data, right? And one thing here, how do you think about this indicator?
Yeah.
What is that?
So that's wouldn't that be
It's
like
a Boolean.
Boolean logic? Yeah. You either have ice or you don't.
It's like a Boolean.
It kind of checks that whether you have ice in the containers, right? So, yeah, I mean, it's a Boolean. Is out of ice or something
It
like that.
would be an operator which
It is an
will
operation.
check the status, yeah.
Now, is it referring to just the ice cubes, crushed ice, or water? So,
Yeah.
It should be referring to the ice.
Yes,
The
it's
other one
referring
has
to the
something
ice.
similar.
Ice. I don't know. Is out of ice indicator is indicate the ice crashed or cube
It
or
could be for both, because if
water.
there is ice cubes, then it is going to crush and output it, right?
yeah. So let's going back a little bit to the dictionary. What I mentioned is there's a method called is empty, right? There's an operation called is empty. So is it like something similar to that out of ice indicator, right?
But see, that time it needs another variable, not just water, right? It needs to have an indicator for the ice too.
Indicator of the ice.
Like the quantity that is stored on the variable, basically, it said water, but it needs even for ice
Oh yeah.
a variable.
So you mean this maybe some data, a value, a variable that indicate the ice, the water.
Yeah.
Yes. So when we talk about this
So
object.
we can have a operation called size, and that would, have the size of each of the containers,
Yeah, and tell maybe more indicator. So
Yeah.
so let me say that. So when we're talking about this, another thing important, encapsulation, right? We do talk about that encapsulation, right? So in terms of good encapsulation, we're not exposing any data directly to the outside, but here the indicator is exposed to the outside. So is it a Boolean value or an operation?
It should be an operation.
Yeah, if we stick to the object-oriented design, the ideas of that, it should be an operation instead of value, Boolean, because we want to encapsulation of the data, right? So here I turn to think this indicator is one of the operations. Okay, got me? Yeah, and water is data.
That would be, is empty.
Yeah, something like that.
What it returns is a Boolean.
I understand we are not, we are trying to encapsulate the data. So in this very case, it says out of ice indicator. Is it crushed ice? Or is it ice cubes?
Yeah,
Or what?
maybe I should say it's out of water indicator. Right,
Water is always
easier, right? It's easier to understand, right? I should say it's out of water. Just think it as out of water, right? Out of water. Okay. All right. So that's ADT. We just modeled, right? Okay. ADT, abstract data type. Right. So why do you think we call what we just did is abstract? What makes that thing abstract? What we just taught. Like data is blah blah blah, operation is blah blah blah. Nice.
It's removing it from the actual implementation.
Yes, yes. We're removing it from actual implementation. So what is the actual implementation of that? Is an actual implementation of an ADT is called data structure. All right, that's called data structure. Data structure include first ADT with the idea, and also the code will implement everything. Right. Now here, if we're going to, if we come here, so if the ADT is what we just taught, water functions, so it's like this. Okay, so what is the data structure here in this beverage dispenser example? What is the data structure? What what may be included in the data structure of this beverage?
Be a static array for holding the amount of ice cubes. So there might be like a limitation that you can check against. Say that
Yeah.
this contains ice or not. Then it can reach a certain point where it's full, so stop making more ice.
Yes, yes. That's definitely should be included in the data structure of it. What else? Check is it full or stop. Yes, that should be it. Should be something included. And what else?
There should be for water there should be some variable or to denote how much water is there. One for that, one
Yeah.
for ice.
Yeah. Right, that's right. Yeah. But still, we still need more things. Yeah, you were mentioning the things like try to check something if we can continue work on this, something like that, right?
Mhm.
And then we still need something in the data structure. Like I mentioned, data structure is the implementation of ADT. So what need to be implemented here? Water? Do we need to implement water? No, water is water. We do not implement water. God implement water, okay? So what we implement is what just said, those functionalities that have maybe assistive functionalities help you to create this ice. And what more essential, the chill water, crushed ice, ice cubes, the implementation of this method. The operations, right? When we define operation of the dictionary with put, get, we describe get is return something, and we say precondition, postcondition of get. We draw a picture of get. Okay, that's all abstract. But implementation of get is the actual code, right? But here the implementation of chilled water is the actual machine that is working in there. Right? They create the temperature, maybe crash the ice. Those machines there that implement these functions, that is included in the actual data structure, right? That's when the data structure comes into play. You define this ADT, you implement this ADT, yeah, data structure, okay? All right, so if it's a data structure, okay, we have this water dispenser design here. We have the actual water dispenser in our hand. Then that is something more like data structure. Okay, when we have that in hand, that is more like data structure, right? So let's think about another question for the data structure. Okay, in hand, the water dispenser in hand. So when you create it, if you are the manufacturer of this, or you're the program of any data structure, you're the manufacturer of this water dispenser, right? When you are trying to implement this data structure, water dispenser, what are the concerns from the manufacturer? So what do you want to think first before you start implement this? Yeah, like the select data structure. What are the concerns the manufacturer might have about selecting a data structure or implementing some data structure? Why? So okay, data types. So why do you have? Why do they concern the data types?
Oh, we're thinking about suitability, if it's suitable for this purpose.
Suitable.
Yeah.
Yeah, we need to consider suitable. If that's actually solve the problem, right?
Yeah.
If that algorithm, if that implementation, that data structure actually solve this problem, okay,
solve the problem, okay, it may not be efficient. We have to think about efficiency.
Yeah, efficiency. Yes, right. And a very important thing.
Customer requirements.
Yes, the cost. Right? When selecting, okay, so I'm gonna implement this chilled water, but I have to buy some parts. That is like a $1 million chilled water creator from some other place. Okay, should I put that in my refrigerator? No, because no one is gonna buy that ever. Okay. So cost. Of course, when we have the cost, the efficiency, right? Whether the algorithm, this module work, the part maybe either I implement it or I pick it from somewhere else. I buy parts from some other manufacturer. Anyway, I need to think if it's work, if it's efficient, and if the cost is acceptable, right? Yeah, something like that. And what are some of the concerns the customer might have about the selected data structure?
Ease of use.
Yes. Yeah, whether it functions correctly, ease of use. Yes. Yeah, does that actually fit my needs? Right, requirement? Yeah. Does it fit my needs? Do I need a crushed ice cubes, chilled water, the stuff? Right? Like my refrigerator at my home, I don't have these things. But I do want them. I do not have them because I get it from the previous owner. I have no choice. But if I have choice, I will have them. Yeah. So that's concerns of the customers. Efficiency, yes. If I have a pretty low cost, but it take like an hour to create some chilled water. Okay, if the guy is pretty thirsty during summer, he's already been died, something like that. Okay, so efficiency, cost, like does it meet our needs? Okay. Yeah. Yeah. Just this are something I want to inspire you to think about, like a modeling or think about something as an object or ADT in the way of thinking. Okay, it's not just like the only answer. What I just say is not like the only answer to those questions. Okay, I just want to inspire you to have this kind of thought, ideas, like this modeling this water dispenser. You can try to model that clock, a computer, this projector, maybe. That's an object, something like that. What is the data? What is the operation? What is elements? What is the relations? Something like that. Yes. Okay.
So when we are modeling this ice cube, the ice dispenser, we are not just looking at the software side, we are also looking at the hardware side, right?
Or what algorithm?
Yeah, I'm talking about, because you refer to the machines that work behind this.
Wow, that's data structure, right? So we're doing data structure. You implement something. Yeah, we're almost done. But I have the lecture video, so you can take a look. Yeah, and you will hear this conversation in the video as well. So. Okay, where are we? Yeah, when we model something, when we're doing this ADT modeling, we first start from a very abstract level. Of course, in the end, we will need this data structure. We will need implementation. But first, you need to start with your design. You need to start with your modeling before you actually implement them, right? If you go ahead, just directly start. Okay, I need a dispenser. I need a chilled water, crushed ice cubes, and just implement an ice cube machine, something like that. Then yeah, it may work for a while, and then if you want to expand your system, it's hard, right? Because this is whole module. You already create a dispenser with water, container, ice cubes, but then you later on you want to add these two things. It's hard. Make a lot of bugs. Okay, so here one more last thing I want to mention here is like the information hiding we mentioned in the the encapsulation information hiding. Okay, how is the information hiding here?
How much ice does these have?
Yeah, absolutely. We have a public maybe operational method that you tell the outside world that okay, this is out of ice indicator. But that's all. That's all I want to tell you. The rest of thing, water inside, whether it is like pure water, or maybe some sweet water. I mean, there's sweet water, or some beer inside. You don't know, right? You don't know. So that's information hiding. Okay, that's information hiding by this wall. And here it's hiding by this wall. In the software world, in the model, it's hiding by the ADT, hiding by the object. This encapsulation, the whole thing. All right. That's all I want to talk about today. Just want to give you some, inspire you a little bit about how you do this modeling and the relations between ADT and data structure, things like that. All right. Thank you very much.